Hi everyone, in this video we're going to look at network address translation. So the purpose of NAT is to conserve the IPv4 addresses, dengan menggunakan beberapa class of private IP addresses. So dalam IP address space kita ada beberapa kelas A, kelas B dan kelas C of special addresses yang kita reserve untuk digunakan secara private. Bila kita kata private ni, maksudnya kita hanya gunakan dalam kita punya internal network and it cannot be routed over the internet. Bila router jumpa, dia akan dia tidak akan forward kepada the outside network, hanya digunakan di dalam internal network sahaja. Okay, so untuk kita keluar macam mana pula? So kita perlukan router untuk jalankan tugas network address translation. So tugas network address translation ni adalah untuk kita translate daripada private IP addresses ini kepada public IP addresses. Public IP addresses adalah those IP addresses yang being allocated by our ISP untuk specifically communication over the internet. So basically kegunaan NAT ini adalah untuk kita conserve kita punya public IPv4 addresses. Jadi untuk kegunaan or connection kepada the internet, the organisation will be allocated only a limited number of public IP addresses, tapi kita gunakan NAT untuk kita gunakan private addresses di dalam network kita. Kemudian bila ada keperluan untuk keluar ke the internet, the NAT router will do translation menggunakan those limited public IP addresses. So in this case, the NAT will be configured on a border router. Border router yang terletak paling dekat to the outside world. So contoh daripada sini, kita ada satu stub network. Bila kita ada connection kepada the internet, the router 2 ni akan examine dia punya source address dan tengok if there needs to be a translation. So bila ada keperluan, dia akan buat translation dan keep track of this information. So inilah satu contoh topology, a very simplified topology. Kita ada this router 2 as the NAT router and this is R1, the stub router that is connected to R2 untuk communication dengan dunia luar. So let's say for example we have PC1. The IP address is 192.168.10.10. Okay. So dia nak access this server with the IP of 209.165.201.1. So dia akan hantar a request lah. So dalam network layer, when router 2 jumpa dia punya packet ni, dia akan tengok the source IP address. Bila dia tengok source IP address ni, dia akan examine whether it's a private or public IP. So when it sees it is a private IP, it knows that dia kena buat translation to a public IP. Okay, so what it does adalah dia akan letakkan ataupun rekodkan information ini di dalam NAT table. So dia akan ambil the private IP address dan letakkan dalam field inside local. Next, dia akan buat translation untuk dia tukarkan daripada private IPv4 address kepada a public IPv4 address. So this translation adalah bergantung kepada jenis translation yang telah dikonfigure untuk router inilah. Okay, but let's say we have one available public IP address 200.226. Jadi dia akan tukarkan the source IP address dalam the IP packet menjadi this public IP. Dan dia akan rekodkan lah. Jadi 10.10 telah ditranslate menjadi 200.226. Untuk the destination IP, dia akan rekodkan di dalam outside local dan juga outside global. For example, here connection ini adalah daripada 10.10 kepada 201.1. Supaya nanti bila kita receive reply, dia akan tengok balik what is the source IP yang reply ni hantar. Okay, so that's the reason we must record both the source and destination. Okay, so now katalah this web server reply dengan a particular web page. Jadi dia akan hantar kepada router 2 dan router 2 again akan examine the source and destination IP, dan bila dia dapati the source adalah 201.1 and the destination adalah 200.226, dia akan jumpa match dalam NAT table dan dia akan buat translation semula kepada the private IP which is 10.10. Okay, so daripada operation ini, I think you will get the idea what the inside local, inside global, outside local and outside global means. So inside address is the address of the device which is being translated by NAT. In this case, it is the PC. Outside address is the address of the destination device. In this case, the web server. Local address is any address that appears on the inside portion of the network, atau maksudnya di sini the private IP, and global address is address that appears on the outside portion of the network, which is the public IP. So the inside and the outside adalah mengambil reference kepada the NAT router. The inside network is on this interface that is configured as the inside. Jadi router ni akan expect dia akan terima a local IP address. Okay, the outside network adalah bila kita configure this serial interface sebagai outside. Jadi anything received from the outside network, dia should expect having a global address. Okay, so macam operation tadi, kita boleh nampak lah daripada PC 1 10.10, bila hantar packet, the source address will be 10.10 and the destination address will be 201.1. Okay, so bila router 2, the NAT router receives this, it's expecting this source address to be a private and it knows that dia perlu buat translation. Then dia akan recordkan lah inside local 10.10 and the outside is the destination. Outside local is here, the web server. So selepas dia terima, dia akan translate. Now the inside global will be 226. The outside global will remain the same. So usually anything outside the network will remain the same lah. Okay, untuk reply daripada web server, again dia akan tengok the source will be the outside local which is 201.1. Sorry di sini and the destination will be the 200.226. Okay, so dia akan refer to this table. Okay, there is an entry, so dia pun buat translation kepada 10.10. So now balik kepada macam mana kita nak configure. So dalam NAT kita ada 3 cara. The first one is static NAT. So in this case, network administrator perlu configure manually the mapping between the public and the private ataupun the inside local and the inside global. Okay, so there is a 1-to-1 mapping. So static NAT ni sebab dia akan bertukar dia punya translation itu sesuai digunakan untuk devices like servers ataupun a particular PC yang you want the outside network access. Jadi kita tak mahu the public IP ataupun the inside global addresses to always change. So we do it in a static NAT kind of way. Untuk dynamic, kita akan ambil a pool of available inside global addresses dan bila perlu, kita akan buat mapping. Bila perlu means when there is a request for a connection to the outside world. So when the router receives a request ni, bila dia terima a packet going to the outside world, dia pun ambil salah satu IP yang available daripada pool dan dia tukarkan, dia buat translation. Okay, once this connection is over, the available IP will be returned to the pool for use by other machines. Bear in mind that this translation is still a one-to-one mapping. Untuk yang memerlukan lebih banyak connection, like usually what we do dalam network kita, kita ada banyak connection kepada the internet. A more viable method adalah menggunakan port address translation. So, cara dia adalah bila kita ada a limited number of global inside global addresses, kita boleh gunakan satu inside global address untuk map kepada beberapa inside local. Okay, so there's a many to one mapping. So macam mana kita nak bezakan connection daripada different PC? For example, kita bezakan dengan menggunakan port address. So for example, here there is one inside global 200.226, but it is mapped to two different inside local, which is 10.10.10 dan 10.11. Apa yang membezakan dia adalah this port number. Okay, so this port number akan membezakan bahawa satu 10.10 adalah connection kepada 201.1 dan 10.11 ni menggunakan port number 1331 adalah connection kepada 202.129. So this mapping ni perlu kita rekodkan dalam NAT table to make sure that it is a correct translation. So macam mana nak make sure kita boleh guna banyak? So sebenarnya dalam ephemeral port number, kita ada this group of available port addresses ataupun port number. Jadi selagi number-number ni available, satu inside global kita boleh translate kepada banyak-banyak inside local. Kita ambil lah satu available port number daripada group ini dan mapkan dia. Bila dah tak ada ataupun habis port number ni, barulah kita move on to the next available inside global address. Okay, so this process continues until there are no more available ports or external IPv4 addresses. So, kita nampak bahawa kegunaan pad ni is very powerful. This is what being used nowadays. Okay, so ini ada comparison between the NAT and pad. Okay, so basically yang obvious adalah dalam NAT kita ada one-to-one mapping, manakala dalam pad kita ada many-to-one. Okay, so yang membezakan again ini kita hanya map kepada IP address, yang ini kita juga map kepada the port number. Some applications yang menggunakan internet protocol tidak ada port number, contohnya ICMPv4. So ada cara berbeza-beza lah mengikut protokol-protokol ini yang menggunakan number lain sebagai mapping. Contohnya ICMPv4 kita gunakan the query ID dalam ICMP format itu. Untuk protokol-protokol lain ada cara, tapi kita tak perlu belajar untuk course inilah buat masa ini. So basically the advantages of NAT is mainly untuk conserve kita punya IPv4 addresses, that it increases the flexibility of connection to the internet, provides consistency for internal network addressing scheme. So bila kita ada satu network addressing scheme untuk kita punya internal line, however kita tukar ISP pun berapa kali kita tukar. So katalah dapat different sets of public IP, tapi internal network kita masih tak perlu bertukar. Lagi satu adalah is a form of security where we are able to hide our internal IPv4 addresses. Tapi NAT juga ada disadvantage. So since kita perlu buat process translation, it increases forwarding delays. And for some applications yang memerlukan end-to-end addressing, benda ni agak susah lah. Tetapi in our modern network sekarang, selalunya application ni ada work around lah. It's still currently working lah. No problem. Cuma agak hassle sedikit sahajalah. Okay. Then again, contohnya bila kita nak gunakan tunneling protocols, masih it can still be done. Cuma it's a little bit more complex. Okay, so to look at the configuration methods untuk NAT, let's look at this topology I've done in the packet tracer. So we have this router 1 to simulate the NAT router. And this here, in the blue square, we have the inside network. In the green square, we have the outside network and router 2 as an external router. So kita ada internet. To simulate this internet, I've done the loopback address. And then the IP addresses are as displayed. So the first kind of NAT adalah static NAT that we're going to do. Let's say the inside network has a server that it wants the internet to be able to access, dan kita gunakan for private IP it's 192.168.1.4, tapi kita nak NAT router ini membuat static mapping ataupun one-to-one mapping between this IP to a particular public IP. So let's start configuring. So the command will be IP NAT inside source. So the source of the inside IP will be the IP of the server. I left out one keyword here. It should be static. And then the static mapping 192.168.1.4, and what should be the inside global address. So let's assume that the IP addresses for the public IP is in this network 209.165.201.5. Now, ini baru kita buat mapping, tapi kita perlu apply kan ataupun kita perlu declare kan the inside and the outside for the NAT router. Let's do a show IP interface brief to look at the interfaces. Okay, so for the interface Giga 01, you must declare it IPNet inside, and interface Giga 00 IPNet outside. So that the router knows when it receives the outside world, it needs to translate into the inside IP. So to view whether our configuration has taken place, we can do the show command, show IP NAT translations. Okay, so there is in the NAT table, the translation of 1-to-1 between 1.4 with 201.5. So here we assume that to the outside world, let's say this PC, if it wants to access this server, what the IP that is published to the outside world is 209.165.201.5. Okay, let me just put a label here. Just to remember the inside global address. Okay, so let's say we try to access this server from PCC. Okay, let's ping 209.165.201.5. Okay, so that's a reply, that's a success. And let's do the show IP NAT translations again to see if there is any translation done by the NAT router. Okay, so now we can see that the router as a NAT router has done its static mapping, static NAT. Bila kita ping, dia akan buat translation daripada 1.4 kepada 201.5 and vice versa. Next, let's look at dynamic NAT. Okay, so dynamic NAT kita ada one-to-one mapping tapi terhadap a pool of IP addresses. So let's assume kita buat the pool of IP address sebagai 10 until 15 slash 24. Okay. 201.10 until 201.15 slash 24. Okay. So we need to do a net pool. So the command is IP net pool dan bagi nama, let's say net pool 1. Okay. And the range of IP addresses 209.165.201.10, and the last IP 15, and the net mask 255.255.0. Okay, so that's just declaring the pool. Then we need to do an access list to permit the inside network lah. Alright, so 192.168.1.0 and the wildcard mask. Now IP net inside, we declare what is the source, which is the 192.168 network. Okay, source list 1 refers to the access list 1. And then what will be the inside global address? So kita refer kepada the pool, and the pool name of my example is net pool 1. Okay, and I've already declared the inside and outside. Okay, so gigabit I've already declared inside and outside. Okay, so we need to do that if we haven't for all the NAT configurations lah. Okay, so untuk dynamic NAT, inilah yang penting, the pool of IP addresses. Then we create a access list untuk define what are the inside local addresses that can be mapped to the pool. And then we do the mapping itself, where in study, not this one, this one, IP net inside source is the access list, and the global addresses is from the pool. Yang ini yang kita buat dalam static tadi. So now let's say PCB wants to access the internet. Let's ping 209.165.200.1. Okay, so this is simulating accessing the internet lah, to the loopback address. So let's look at the translations now. So we have a translation for the PC whose IP address is 1.3, and the inside global is it takes from the pool. Kita start dengan 10, so it takes the first available pool of IP 10. Okay, we can do a clear of the net table using the command clear IP net translation and the asterisk. Okay, and then show. Okay, so now there's no mapping except for the static map tadi. Okay, so but we know that it's working lah. Let's do a ping also from PCA. So we do a show again. Okay, so again we have PC 1.2. Okay, so now selepas dah habis daripada PCB, dia bagi balik pen ni, okay, to the pool and create a new translation. This time using also the port number 1234. Okay. So tadi kita tengok dia pakai IP yang sama bila kita clearkan IP NAT translation. So now I clear again the IP NAT translation. Okay, so there's only one-to-one mapping. Let's do a ping from both the PCs. One ping daripada PC B and another ping daripada PC A. Okay, now let's look at the translation. So now dia akan ambil the available IP and we see that there are two different mapping between 1.2 dengan 1.3. 1.3 adalah PCB and 1.2 adalah PCA, and they take the IP that is available from the pool, which is 201.11 and 201.12. So you can see that there is still a one-to-one mapping. Okay, the port number is for sequence between this one-to-one mapping. Okay, so 11 untuk 1.3, 12 untuk 1.2. So that's dynamic NAT, still a one-to-one mapping, except that we have a pool of IP addresses yang boleh digunakan or reuse. So I've shown that bila kita buat satu sahaja tadi and we clear, the IP 201.10 has been taken back to the available pool of addresses. Bila saya ping kali pertama untuk B, maksudnya 1.3 map to 201.10. Kemudian it's being returned to the pool and I ping from PCA. So 1.2 has a mapping to 201.10. And then it's being written. Okay, so now bila kita ping sekali, dia akan ambil a different IP lah, 11 and 12. Selain daripada show IP NAT translations, we can also do another command, show IP NAT statistics. So this is a little bit more detailed, right? So dia boleh tunjuk what are the inside and outside interfaces and what are the available mapping. So for example, we have a dynamic mapping yang kita dah buat tadi. Okay, finally, kita nak tengok CAD, which is basically just a slight modification to what we have in dynamic NAT. Okay, so instead of kita guna one-to-one, and then a different set of inside local map to a different inside global. Now kita nak map to as many as possible inside local, one inside global. So let's assume this is the IP that is public and being seen by the internet to reach this network. Okay, so kita nak apa-apa yang keluar daripada sini. Okay, maksudnya menggunakan alamat 230 ini. Sesiapa pun lah daripada sini, the source IP will be 200.230. Okay, so dia gunakan satu inside global untuk multiple inside local. So first I do show IP interface brief to look at the name of the interface. Okay, so it's gigabit Ethernet 00 and the IP is 209.165.200.230. Okay, so now we do a IPNet inside source list 1. We already have the list 1. Okay, and then we do interface giga 0/0, which means the outside. Okay, and then we add the keyword overload. Okay, so yang lain kita dah buat, which is the access list. So I do a show run command to verify. Okay, so gigabit ethernet 00 kita dah buat IPNet outside. Gigabit ethernet 01 kita dah buat IPNet inside. Okay, and then we also made a IPNet inside net pool, and then in IPNet inside source list 1 overload. So overload ni adalah the right portion. This is the dynamic net and this is the static net. The access list is already there. Kalau kita buat satu persatu means kamu kena go through all the steps lah. Maksudnya access list ni kena buat and interface inside dan outside kena buat. So those are the steps lah. Okay, so I've added additional PC here. Let's name this PCD. Okay, just to view whether our pad is working. Okay, and also I've cleared the NAT translations, okay, so that we can view on a clear scale. So let's ping the internet to 109.165.200.1. Okay, also from this PC. And let's ping from PCA as well. Ping 209.165.200.1. Okay, so now we've pinged the internet from 3 different sources. Let's do a show. Okay, let's ping again. Okay, so maybe some time has passed after I've pinged. So now I've done the pinging again. All right, so we see that 3 different sources, 1.5, 1.2, and 1.3 are the inside local using the same inside global, which is 200.230, which is the IP address of the gigabit interface that we declared as the outside network here. Okay, this IP, and what differentiates the different connections adalah dia punya port number. Okay, so dia akan gunakan all the ephemeral port number to differentiate the connections. Okay, so kita ada 201.10. Okay, so dia akan gunakan 10 and 10 ni. 11 and 11, 12 and 12. This is the different connection. Okay, so this port number will be used to differentiate walaupun dia datang daripada IP inside global yang sama, tapi dia akan differentiate which are the inside local yang berbeza. Okay, so that's it for the NAT configuration. 1, we've configured the static translation, which is the server 1.4, and we made it to 201.5. Then kita buat dynamic net dengan menggunakan a pool of IP addresses. Again, saya show run. Okay, so this pool of IP 209.165.1.10 until 15. And then we did a pad using the keyword overload. And one example adalah kita nak hanya gunakan satu IP sahaja, which is 200.230. Let's say we do not want the pad to use only one IP and kita nak gunakan a pool of IP addresses juga macam kita buat di sini. Okay, NAT pool 1 which is 201.10 and 201.15. So that's the range of IP. Let's say we create another range of IP addresses. We can also do that. Okay, so let's do that. So let's say I want to cancel what I've done for the interface. Okay, so no IP net inside. Copy. It's okay. Let's do a show run. See if it's being removed. Okay, sudah tak ada. So now I want to do a pool. IP net pool. Net pool 2. The range of IP addresses adalah kita sambung lah. Okay, 16. Sampai 209.165.201.20. Let's say. Okay. Two five five dot 255.0. Okay. Access list kita dah ada. Okay. Then we configure the net inside source list 1. Okay, which is the access list of this one. Permit 192.168.1.0/24. And now we point, instead of point to the source of gigabit ethernet, kita point kepada pool. Then don't forget the overload. So overload ni lah yang membezakan dynamic net dengan PAT ataupun port address translation. Okay. Then inside and outside dah ada. Right. Okay. Let's do a clear. So it's clear. Let's do a ping. Okay, I ping again. Let's do a show. Okay, so we can see that having coming from 1.5 and also 1.2, 1.3, dia gunakan IP available daripada pool which was beginning from 16. So selagi ada port address ataupun port number yang available, dia akan gunakan IP yang sama sahaja sehingga dah habis port number tu, which untuk simulation ni it's going to take a long time lah. Right, so dia akan gunakan IP yang sama sehingga dah habis port number, barulah dia tukarkan kepada the next available pool. So that's why we see that we have a limited number of public IP addresses, but it is still enough untuk connection daripada multiple machines. Contohnya dalam UiTM kan, we have a lot of students accessing the internet at the same time, but we can still use a pool of public IP addresses to give this connection to the outside world. So that's a little bit of the demo for the configuration.